At points in the system where liquid is present, the actual liquid temperature will be at or below the temperature indicated on the PT card. Liquid will be present in the liquid line, which connects the condenser and evaporator coils. Let's examine the gauge we have installed at the outlet of the condenser coil. The measured pressure is 155 psig. Assuming there is minimal pressure drop in the condenser coil, we will have a 155 psig pressure in the coil. 155 psig on the PT card indicates a temperature of 114 degrees Fahrenheit. Because liquid and vapor must be present in the condenser coil, we must have a 114 degree Fahrenheit refrigerant in the coil. If we were able to place a thermocouple on the coil surface where the refrigerant was condensing, it should reveal this temperature. If 114 degrees Fahrenheit is measured at the condenser coil outlet, we know the refrigerant is still saturated, and we likely have a liquid and vapor refrigerant mixture entering the liquid line. However, our actual measured temperature in this case is 105 degrees Fahrenheit. Because this temperature is lower than our saturated temperature, we know the refrigerant at this point is subcooled liquid. To determine the amount of subcooling, simply take the difference between the measured temperature and the saturated temperature indicated by the PT card. In this case, the difference between 114 degrees Fahrenheit and 105 degrees Fahrenheit is 9 degrees Fahrenheit. With most systems, one can expect to find the refrigerant in the liquid line to have some amount of subcooling. In particular, systems employing a TEV should have subcooled refrigerant liquid entering the valve. When a system employs a liquid receiver, we will find saturated refrigerant at the liquid-vapor interface in the receiver. If the measured pressure in the receiver is 155 psig, we know the temperature at the refrigerant level to be 114 degrees Fahrenheit. The fact that saturated refrigerant exists in the receiver is at times a source of confusion and does not mean subcooled liquid cannot exist in a receiver. If the condenser provides subcooled liquid to the receiver, subcooled liquid will be present in the receiver also. Only the liquid-vapor interface in the receiver must be at saturation. As another example, let's take readings at the TEV inlet. Our pressure gauge reads 150 psig, and our measured temperature is 104 degrees Fahrenheit. To calculate our subcooling, we again reference our PT card. 150 psig on the PT card indicates a temperature of 112 degrees Fahrenheit. The difference between 112 degrees Fahrenheit and 104 degrees Fahrenheit is 8 degrees Fahrenheit.